Okay, so when we want to look at enzyme affinity, that is when we want to see how well an enzyme can bind to its substrate as to know how quick a reaction is going to happen. So to measure enzyme affinity, we measure it by looking at the Michaelis-Menten constant, which is represented by Km. So when we're going to do that, we would have a graph of substrate concentration versus our rate of reaction, and we can plot the points for substrate concentration on the x and the rate of reaction on the y. And from those values, we will always get this curve that will eventually level off if we're plotting substrate concentration and rate. So to find the Km, what we need to do is where the curve levels off, you can measure that off of the y-axis. So wherever we start getting our straight line, we can plot and we can go across to the y-axis. And that point where it's leveled off, we call the V max. So it's the maximum velocity. So it's the maximum that the enzyme can work at. And in order to find the Km, we can take this Vmax value and we can find the half of Vmax. So if I read off here, I can see that my Vmax is approximately 0.08. So I can say half of Vmax is going to be this divided by 2. And that divided by 2 is going to be 0.04. So now I can find 0.04 on my y-axis, and I can say this is the half Vmax over there. And I can then draw a line across to my graph from that half Vmax, and where it meets my graph line, I can draw that down to my x-axis, and that point on the x-axis over there is going to be the Km. So I can read off and I can say that my Km is then going to be 0.04, let's say 2, approximately from there. Then the units for your Km and your Vmax are whatever your units are for your axes. So if this is in millimoles per decimeter or moles per decimeter, anything like that, that's going to be the units for your Km. But this is not super accurate. If we want the most accurate, what we have to do is we have to plot a graph of reciprocals. So what I want to do is I want to invert my substrate concentration and my velocity. So if I have my table of units like that, what I can do is I can say 1 over my substrate concentration and 1 over my velocity. So I literally just take 1 on my calculator and divide it by each of those values. So 1 divided by 0.02, I get an answer of 50. 1 divided by 0.04, I get 25. Then my next one, I get 16.7, 12.5, 10, and 5. And then the velocity, I do the same thing. I say 1 divided by 0.025, and on my calculator, I get 40. 1 divided by 0.041, I get 24.4, then 19.2, 16.4, 14.9, and 11.8. So now I can take this reciprocal and put this on the x-axis, and I can take this reciprocal and put it on the y-axis. So I can take this value on each graph. So I can plot 1 over the substrate concentration on the x, and I can plot 1 over the velocity on the y. And when I plot all those points and I join them together with a ruler, I will get a straight line. But what we do with that straight line is we can extend it to my y-axis and down to my x-axis. So I can go like that through my lines, and I get a point on there and a point on there. And those points can give me the reciprocal of my substrate concentration and my velocity, which would end up being my Vmax and my Km. So over here, through my y-axis, I've got 1 over V. So I can say that my 1 over V looks to be approximately 8. And now I can get that as just my Vmax by saying 1 over the Vmax equals to 8. So I want Vmax by itself, so I can take that with the 8 and swap places. So I can say that the Vmax equals 1 over 8. And when you type 1 over 8 into your calculator, you get 0.125. Then I can do the exact same thing with my x-intercept, but now just note that that's going to be on the negative side. So I can say that my negative 1 over the km from the x-axis is going to equal what I have on that side, so negative 14 for my intercept on the x-axis. So then I can swap places with my km by saying that my km is going to equal my negative 1 over my negative 14, and the negatives cancel out, and 1 over 14 in your calculator is 0.071. So there I have the km and the Vmax by plotting the reciprocal of the graph. And the whole point of getting your km value is because we want to see what the enzyme affinity is. So the lower the km value, so when km is low, that means it has a high affinity, because that means that there's a very quick reaction taking place, so the enzyme and the substrate bind to each other very easily. As the km gets higher, the affinity gets lower, because it means the rate of reaction starts to get slower, so that the enzyme doesn't really like the substrate as much. So we've just got to remember a low km value is what we want, because that means there is a high affinity.